Hello students, and welcome to the first calorimetry lab. This calorimetry lab, what we are going to do is be measuring the enthalpy for reaction. We are going to be using two compounds today. We are going to be using copper 2 sulfate, and we are using a 0.2 molar solution. And we are also going to use fine zinc powder. Okay? For this lab, a couple of things that I want you guys to go ahead and take note of. Zinc in and of itself is not very flammable. When you powder it, it becomes infinitely more flammable. So this is a lab that you want to be very careful to make sure that there are no open flames. Otherwise, it will go ahead and go up in flames. Okay? Copper 2 sulfate, it is, could be relative irritant. However, as long as you're being safe and making sure to wash with water, if you do get any on you, you should be fine. Okay? Now, what we are going to do here first is we are going to go ahead and make our calorimeter for this lab. And a calorimeter is essentially a device that we're going to use to make sure that we don't lose any heat to our surroundings. We're trying to mitigate the amount of heat that's lost to our surroundings, because any heat that is lost to our surroundings is going to be heat that we are going to be unable to use in our measurement. Okay? Now, luckily, the calorimeter is something that we have been blessed with at our school, as in we have a brand new set of calorimeters for us to go ahead and use. And I'm going to go ahead and get it here. Just a second. It's a little... Okay. And I have it right here. We have 2 coffee cups. Okay. This is the basic form of a calorimeter. We use styrofoam coffee cups, and it has a nice fancy top of a styrofoam plate. Okay? Now, the reason that we have those is because this right here is what polystyrene looks like. Okay? And it's just an ever-repeating thing of this carbon backbone with carbon rings on top. And that ring and that carbon backbone are all nonpolar, okay? So it's a nonpolar covalent compound. We already learned earlier that in general, nonpolar covalent compounds are going to be non-conductive to heat. And this one is just particularly really good at being non-conductive to heat. So the lazy chemist in us go ahead and use this as our basic calorimeter. Okay. For our lab, we're going to go ahead and do it twice. We're going to have 2 things that we're going to look at. First, we're going to have an experiment where zinc is limiting. Then we're going to have one where copper 2 is limiting. And what's going to happen here is that we're going to go ahead and time it so that every 10 seconds, not 10 seconds, but every minute, we're going to go ahead and take a measurement. Okay, just a second. I'm going to pause and double check that. All right, and I verified it. We are going to keep it going for 1 minute. Now, for our first experiment, we're going to go ahead and start by measuring out. Now, first we're going to get our coffee cup calorimeter set up. Okay, and it's going to require us to have a beaker as well. We're going to place it here, and then we're going to take our thermometer probe, and now we have set up our coffee cup calorimeter. Okay? Now, some of you may be thinking, no, there's no way. Mr. Bradley's being too lazy. Nope, this is the most basic way for setting up a coffee cup calorimeter. This is how we do it. Okay? we're going to go ahead and take in and put in to our coffee cup calorimeter 25 milliliters or 25 centimeters cubed of our copper solution. Okay. So it's 25 centimeters cubed. And then we're going to go ahead and start with the zinc limiting reaction. Okay. So our reaction is going to use two different amounts of zinc. The first one, we're going to try and use 0.64 grams. Now zinc is really, really dense, so be aware of that when you first get it. And here, I'm going to go ahead and write what our official number was. We ended up getting 0.6450 grams of zinc. Okay, so that's our amount of zinc for the first one. 0.6450 grams of zinc. Okay. We're going to start by putting our thermometer, our probe, into our solution. And once it's in our solution, we're going to be able to measure the temperature. Okay? And this is going to be our starting temperature, all right? So our starting temperature, or temperature 0, is going to be 21.1. Okay, we're going to go ahead and then make sure that we have a timer. And we're going to We might as well get our calorimeter in the shot too. That's as good as we're going to get. Okay. This is our timer. We have the temperature right there as well. What we're going to do is we're going to go ahead and pour it in, and we're going to measure it every minute. One minute has passed, 21.9. Two minutes has passed, 21.9. Three minutes has passed, 22.2. Four minutes has passed, 22.4. 5 minutes has passed, 22.6. Six minutes has passed, 22.8. Seven minutes has passed, 23.0. Eight minutes has passed, 23.2. Nine minutes has passed, 23.3. 10 minutes has passed, 23.5. Okay, we're going to give it just a little bit more until we start to see a curve down, because we should see one down coming down here shortly. Eleven minutes has passed, 23.6. Twelve minutes have passed, 23.7. Okay, so when you're doing a lab like this, you're going to want to make sure that the temperature has stopped or is starting to go down. That's when we're going to know the full temperature increase or decrease. Okay. Thirteen minutes have passed, 23.8. Fourteen minutes have passed, 23.9. And 15 minutes, and we're at 24.0. 16 minutes. We're at 24.1. Okay, 17, 24.2. This should have stopped a bit ago, but I guess not. Okay, this is the last one, 17, and it has stayed still. So we're going to go ahead. Reminder that our last measurement was at 18 minutes, and it ended up being 24.3. It ended up being 24.3. So our data table is now going to look like this. I'm going to splice and add this to our last little video from before, and hopefully it'll end up being what we need. These are the numbers for our data table.